Alright, good morning boys and girls. Great to be with you here today. Hope you remember me. I'm your video instructor, Mr. Leo Machado. And our science topic for today is air, water, and weather. Air pressure. Well, before we get started, I have a little video I want you to watch. Let you realize what we're going to do today. Let's take a look at it. Alright, boys and girls, that was an example of how powerful air pressure can be. So, let's move on with our lesson. We'll get a little more into it as we continue. So, let's go ahead and watch that video one more time. This time we have a little bit different. Looks the same, but a lot larger. You may have seen some of these. Whoa! Oh my!
760. Gewonnen hat Herr Cocktail.
Alright, boys and girls, you may have seen some of these tankers before. Now, how did that happen? What happened here? You take a look very closely. I'm very shocked. How did that happen? Well, as we go through today's lesson, we'll try to answer that. So, what is pressure? How does air pressure work? Is air pressure strong enough to crush things like the tanker? Why don't we feel the air pressure? And why doesn't it crush us? These are some questions that were asked by you, and as we go through today's lesson, we're going to try to answer those for you. Great questions, by the way. So, what is pressure? Well, we take a look here. Pressure happens to be, let's see a good definition of pressure. Alright, it's force created when matter comes into contact with other matter. So we look at the sponge here. The contact that's taking place is the hand that is actually squeezing this sponge here. So the contact between both forces there is pressure. Let's go ahead and feel pressure for yourself. See if you get a better idea. Alright, boys and girls, can I have everybody stand up? Alright, gentlemen, I need everybody to stand up, please. What I'd like you to do right now is, I'd like you to try to bend over just like this young lady is bending over now. What you're going to do is, it's kind of like push-up position we call it here. What you're going to do is get your hands, lay them flat on the desk in front of you. And if you notice, what I'd like you to do is I'd like you to go ahead and push down right now. Very softly, not too hard. Now go ahead and really try pushing down hard. What you feel there is pressure. The force that's being exerted by you is actually also being given right back to you by the desk. The desk is also having the same force being pushed right back towards you. So what you feel there is pressure. Alright. You can go ahead and get up and have a seat. Thank you. Alright. So how does air pressure work? Okay, we will feel that pressure. Let's talk about air pressure. Well, let's think for a second, boys and girls. Let's name all the things that are putting pressure on you right now. So, can I have a volunteer come to the mic and tell me, what are all the things that are putting pressure on you right now? Look around you. Some of you may be sitting down on it right now. So, can I have a volunteer come to the mic and share with us all the things that are putting pressure on you right now? I'm going to give you 20 seconds to think about this. Then if I can get a volunteer to come to the mic, please. All right. TAI 5A. Can I have a volunteer come to the mic, please?
Yes, the things putting pressure on me right now would be my chair, my clothes, and my boss, Kunal Chawla.
All right. I feel the pressure as well. So I believe I heard you say the chair and perhaps your boss as well. And if you notice around you, there might be something as well, which is indeed air that's also putting pressure on you. Thanks for coming up, and I appreciate that. You may return back to your seat. So let's go ahead and let's feel air pressure for yourself now, because we talked about air here. All right, let's take a look at this young lady here. What I'd like you to do for me right now is I would like everybody to close their lips, and I want you to blow without letting any air out. You're going to fill your cheeks up with air as best you can. I'm going to give you 10 seconds. Go ahead and try that. All right, boys and girls, you can stop. Don't want you to pass out on me there. All right. So as you notice, you can feel the air pushing up against your cheeks. You probably can also feel it pushing up on other parts on the inside of your mouth as well. But you really feel it on your cheeks. So what you feel is that air pressure against your cheeks. So now you have an idea of what pressure feels like. But you have to realize there's air around us that's putting pressure on us. But the reason why we technically don't feel it right now is because you're not really used to it. We'll get into it a little later. So let's take a look at this video on air molecules. Alright, so if you took a look at that video, you saw the molecules bouncing off of that container there. And as we previously discussed, molecules in the form of gas can move around freely. And they're bouncing around. So in your room right now, there's actually air molecules that are bouncing around in the room with you being in there right now. And as you can see, you can't feel that. Your body is used to it. You may not know it's happening, but it is indeed happening. All right. So, changes in air pressure. If we take a look here, we notice that if you look at A over here, we have less air molecules in there. Because there's less air molecules in there, there happens to be less air pressure. B, we've added more air molecules. Therefore, we added a little more pressure. And if you notice C, C is full of air molecules. Therefore, because it's full of air molecules, it's full of more pressure, which will come in handy later. So as we talked about, A has less pressure, B normal pressure, and C has high pressure. So another question that was submitted by you is air pressure strong enough to crush things like the tanker? Let's think about that for a second. Is it strong enough? Well, let's take a look at this video here of a steel drum being crushed.
You know, you look at the surface area of this thing, it's probably something like 20 square feet. So we're talking about 40,000 pounds of force on this thing. That's like one of those 40-foot school buses.